Hi, I'm Stevie C and the place to be. My project and video upload schedule has been nobbled by several of these things. Don't worry, I'm sticking to electronics and not veering off into mousetrap reviews. You'll also notice that I'm experimenting with a different bench cover. Let me know in the comments down below if this looks better or worse than the old one. In this video, I want to show you an LED signage PCB I designed for a local shop proprietor. Like many of my videos, this was inspired by a big Clive project, in which he demonstrates what he calls a scripting sign. This is based on two 555 timer ICs, shift registers, MOSFETs, and a crap ton of wires and LEDs. I didn't really know anything about how to implement shift registers before this project, but that's kind of the point in me taking on these projects, to learn stuff. Also, as we've seen before, I'm not a fan of freeform wire structures, Veroboard, or using materials like wood to hold components in place, as per Clive's video. So, I've done my usual and designed a circuit board in Sprint layout, and had it manufactured by JLC PCB. But I may already have come a gutser. Perhaps you can spot how. As you can see, I've added these numbers onto the silk layer in Sprint to help with drawing traces in and out of the shift registers, except I've also bounced them out to the Gerber file. Let's hope I've not included any mistakes like last time. Just a note from Future Stevie here. I haven't released that video yet. Speaking of videos that haven't been released yet, I thought about using a PICAXE 40X2 to drive this whole thing, as it natively has enough I/O on board to drive multiple channels of LED animation, just like in another unreleased video. Anywho, I'm here to talk about shift registers, not a video I haven't finished yet. And yes, I probably could use an Arduino, except I don't know how. The PCB lettering is in the form of the Das Volt Zeichen 7x5 characters in two sections. The top section, which will spell the name of the shop, uses standard 5mm LEDs, which will be sequenced from the 595 shift registers via transistors. Though I'm not entirely sure the transistors are necessary, as I'm pretty sure the shift registers can drive the LEDs directly at a high enough current. Anyway, the shift registers will be controlled by a PICAXE 08M2. I've included several spaces for electrolytic capacitors in case of severe voltage fluctuations caused by the LED chases. Then we have the lower section. This will spell OPEN. It'll use 5mm RGB diffused LEDs and will be controlled by a PICAXE 18M2 processor via more transistors, one per color channel per letter. Yeah, I could have spent a bit more time on the design and had one processor driving everything, but I didn't. There's always version 2.0. Actually, I'll be honest, I just spent so long on this and was starting to get tired of designing it and just wanted to push something to manufacture. Also worth noting is that I can use standard 2-pin LEDs in place of the RGB ones, and reflect this in the transistors and resistors being populated, and of course the code. I want to draw your attention to the way I've drawn the traces for the RGB LEDs. You'll see the positive coming in from one side of the character grid, and the negatives coming in from the other. This is to prevent one end from being noticeably brighter than the other due to voltage drop. I was having a problem visualizing how to code for driving shift registers, so I prototyped the configuration on breadboards. Ignore the fact that LED 1 is green and out of sequence. I was just experimenting with transistors and base resistors. Also, ignore the 555 circuit. I was originally going to use a 555 to control the registers just like Big Clive, until I opted to use a PICAXE instead. In the finished product, my PICAXE will be essentially automating the actions that my fingers will be performing in this demo with the tactile switches. We have serial data, latch, and clock switches. There are capacitors across the switches for debounce purposes, although there's still some weirdness. This weirdness should in theory be eliminated by much quicker and much more precise switching by the PICAXE. So to clear the display one LED at a time after initial power up, I'm alternately pressing clock and latch. All clock is doing is creating a timing pulse that pushes data into and along register 1, then out into register 2, and so on. Pressing latch is copying the data in the storage register onto the output pins. For the moment, I'm not touching serial, so no new data is being input. To show the latch working another way, I can repeatedly press clock only. thus shifting a string of zeros into the registers while not affecting the output. Now I can go ahead and press latch and only now affect the LEDs. So now I want to write a basic fill and empty chase sequence into the LEDs. For this, I hold the serial switch on, while alternately pressing clock and latch to write the data into the registers and update the LEDs simultaneously. I can also hold serial on and clock the data in, leaving the latch command to last. The next pattern I want to try is to clock 5 LEDs worth of data in, then shift that along to light one letter at a time. And again, I can do this either by shifting 1 column's worth of data or 1 letter's worth of data. You might still notice some erraticness in the LED pattern. This will still be due to the way the tactile switches operate, i.e. not perfectly. This shouldn't be an issue in my code. So now I just have to convert my finger actions to the basic programming language. Which is kind of cool when you think about it, because I can control 50 LED channels with just 3 data wires and 2 power wires. I might add output enable and reset control lines in version 2, I don't know yet. So the first thing I have to do is kid you on that I stopped filming to go spray paint the PCB black, which I've actually done in advance. Yeah, the paint job isn't perfect, but it's a prototype and it'll get the job done. The soldering order will be the usual, in order of height and fiddliness. So resistors first, then DIL sockets, then LEDs, etc. I'm going to socket the PICAXE chips, as they'll probably need their firmware updated repeatedly. More on this later. The shift registers will just be hard soldered. I really hope this design works. Only one way to find out. So cue the music and cue the time lapse. This has only just occurred to me, but I'll need to use different values of resistor depending on how many LEDs in a particular letter column I'm driving. In the letter L, for example, if I used 100 ohm resistors for every channel of the letter, the first column will have 7 white LEDs sharing 20 milliamps, whereas the next column would have a much brighter single LED with a full 20 milliamps to itself. I've settled on the values of 47 ohms for 6 or 7 LEDs, 100 ohms for 4 or 5 LEDs, 150 ohms for 3 LEDs, 180 for 2, and 330 ohms for a single LED. This should run each LED between 4 and 7 milliamps to hopefully keep them evenly illuminated. As for transistor base resistor values, I have no idea. I did the base resistor calculations in technical studies at school and not since. I'm guesstimating 1K for the moment. This is a prototype for a reason. Anywho. As for the RGB LEDs, I'm using 47 ohms for the red channel and 27 ohms for the green and blue channels. I forgot to order the 27 ohm resistors, so they'll be installed at a later date for me, and in about 5 minutes at the time of editing for you. As I said earlier, I'm hard soldering the shift registers, using blue tack to hold the chip in place. The technique I'm using for the 2-pin LEDs is using blue tack to hold the LED roughly in place while I apply solder to one pin, then aligning the LED flush with the PCB before soldering the other leg. The RGB LEDs are a bit more involved. I'm hoping you'll appreciate the fiddliness of aligning an LED with 4 pins, making sure to observe the polarity, as the even columns are polarity reversed. Blame the PCB designer. Add to the existing fiddliness my less than perfect spatial coordination, the fact the workshop is about 4 Celsius on a good day, hence the overalls, and the fact I had a raging hangover for some of this video. As I discovered in my TrueSemi M34 video, my preferred method is to solder one leg first, then align the LED as before, but then crop all the legs down, and only then solder the rest of the pins. I've also found that replacing my knackered soldering iron tip helps. I'm testing the RGB LEDs with the meter to check for shorts, just so there's no nasty surprises later on. It all looks good. Also, I decided it was Bring Your Pet Tiger to Work Day. And my rapid electronics order with the resistors has arrived. Now it's time to install the NPN transistors. I'm not sure if these are overkill, as the shift registers could probably drive the LEDs directly at a high enough intensity. Also of note is that spray painting the board black has blocked some of the component holes. I'll admit that I'm just throwing in a few different random values of electrolytic capacitor here. Right, I'm going to be honest here. I cheated very slightly by testing the PCB off camera, because I was just so anxious about the possibility of it not working. I had a bit of weirdness where initially only the first letter lit, with the rest doing a weird flicker thing. Then only one LED lighting. I had that crushing, oh no feeling. I didn't know if it was a faulty transistor, or maybe the shift register had either arrived dead or had gone bad during soldering. I don't know. But now I can't replicate the fault to show you, which is worse in a way, as I don't know if it will reappear at some point in future. I'm putting the weirdness down to the PICAXE just not being seated correctly in the DIL socket. This is the old pattern from the breadboard, so obviously the code isn't correct for the number of LEDs there are, because obviously there's a lot less on the breadboard, which only had 4 shift registers to this PCB's 7, even though the last one isn't fully used. But just so you're not hard done by, here's the genuine first test of the sign as a whole. I see a problem. Oh boy. I wish the blue's correct. This should be easy enough to fix. I just have to swap the green and red pin declarations. I've obviously got confused. So as I mentioned before, I'm just using the PICAXE to switch high and low to simulate my fingers on the pattern switches. Here I'm just initializing the chip and creating subroutines for each type of chase. Here I've written the code to create one character and chase it along in that pleasing manner from the breadboard version, with less outputs than there were LED columns. Here I'm writing the fill then empty effect. You get the idea. It's not big and it's not clever, but it does the job. When it comes to writing the code for the open part of the sign, I'm just switching different I/O pins to create red, green, blue, cyan, magenta, yellow, or white in different combinations for the chases. Once I'm happy with my code, it's time to plug the PICAXE back into the programming breadboard and press the magic button. Then pry the chip out of the breadboard for the umpteenth time and plug it back into the display PCB for a test. And obviously do that for both of them. What's going on with this N? How have you got mixed up twice? So here's the PCB doing its thing with the final, new final for sure, definite final revision of the software, or firmware, or code, or magic. And here's the PCB doing its thing at the Lighthouse shop in Forfar High Street. I don't normally talk about costs and price in my videos, so just out of interest. The board itself costs about 20 quid, the LEDs about 15 quid, capacitors 3 quid, resistors a couple of quid, DIL sockets probably the same, transistors 4 quid, shift registers 12 quid, PICAXEs £11.50. The USB cable came from Poundland, so obviously it costs £1.50. Then I'm not including the solder or the electricity for the workbench. So that's £71 cost before I've even whacked on the markup I need to in order to stay in business. Yes, I could order much more in bulk if I was making up a whole pile of them, but you'll see where I'm coming from. Most people are going to balk at the resulting sale price. So my idea was to offer this on a lease agreement. I just thought what with micropayments and subscriptions being the in thing these days, it may make a more enticing proposal. Granted, it means you never actually own the PCB, but it could include a service agreement for components to be replaced if needed, and the animation firmware to be updated if requested. Anywho, if you like this project and or want to share it, you know where to click. If you aren't subscribed, please consider doing so. And I'll see you for the next one. Thanks for watching.